In this video, we will graph some linear equations and compare them to graphs of absolute value functions. So when I graph a linear equation, I like to think of the model y equals mx plus b, the slope-intercept form of the line. Because I can see that the y-intercept of this line is going to be -5, so I would put my first dot there. Now the slope is 2. That means we will go up to right 1 from the y-intercept. So up to right 1, repeat, repeat, repeat. Repeat, repeat, repeat. And I could put a couple points going to the left by going down to left 1. All right, so these dots show what this graph is going to look like. And then you would just draw the line going through those points like so. And that's how you graph a linear equation. Now it takes an extra step or two if the equation is given to you not in slope-intercept form. So I would just rewrite this equation is all. So here I've got this equation 2x plus 3y is equal to 6. Basically, I need to get this y by itself. So I would subtract 2x from both sides. So now that gives me 3y is equal to -2x plus 6. Now I'm going to divide everything by 3, like this. So that's going to give me y equals -2/3 x plus 2. Now this I can graph easily. The y-intercept is 2, and then the slope is -2/3. So that means down to right 3. So if I go down to right 3, repeat, repeat, and going to the left, it would be like up to left 3. So up to left 3, up to left 3, up to left 3. So there's my line. And so I will draw my line through all of these points. Whoa, it's a big jump. Okay, so there you go. Now, compare these equations, compare these graphs to what I'm about to do with these absolute value functions. See these do you see the absolute value symbol, these vertical bars here? That tells you that this will not be a straight line. In other words, instead it's going to be some type of a V. If it's negative, I know it's going to be some kind of an upside down V, like this. If it's positive, then I know it's going to be some type of a right side up V, like that. But they will not be straight lines. I'm emphasizing that because every year I have students take a look at this and they want to just give me a straight line. Don't do that. Instead, think about where the vertex is going to be. Now, the parent function, absolute value of x, the vertex is at the origin and it goes up 1 over 1 from there. So compared to that, this plus 4 is going to shift the graph up 4. So that means the vertex is going to move from 0, 0 to 0, 4. Now from there, I know it's going to be an upside down V because of the negative. So it's going to be doing something like this. But I don't want to estimate. I want to use this to help me know the slope. So this will give me the slope of the right-hand side of the V. So -1/2, that, think of the negative as being on the 1. So down 1, right 2. Down 1, right 2, repeat, repeat, repeat. Now because this is a V and not a straight line, when I do the left side, I'm not just going to keep going up. I'm going to do the mirror image and go down 1, left 2, like this. Okay? And then I can draw my function from there. I messed that up, didn't I? Maybe I can fix it. So the graph should look like this. Now, similarly, the transformations here are right 2, down 6. The left-right motion is always the opposite of the way it looks. So right 2, down 6. So that puts my vertex here. Now this is an upward-facing V. For the right-hand side, I can use the slope. This invisible number in front is an invisible 1. So I'm going to go up 1, right 1 from the vertex. But this is absolute value, so I got to V it up. So for the left-hand side, I'm going to go up 1, left 1, like this. Okay, and then I'll just draw the graph from there. All right, so your graph is going to look like this. Now, briefly, let's speak about the domain and range. The domain, it goes left and right forever, so that's going to be negative infinity to positive infinity. Range is the y values from bottom to top. So the lowest point, well, there is no low. It goes down forever, so that's going to be negative infinity. The highest point is at a y value of 4. Put a bracket on it. It's included. It touches. For number 4, the domain again is negative infinity to positive infinity. The range, y values from bottom to top, that's going to be negative 6 to infinity. It goes up forever. Okay. Now let's go ahead and graph these piecewise functions. So when you're graphing a piecewise function, there's 2 ways you can do it. You can do it without a calculator, or you can do it with a calculator. So I'm going to graph this one without a calculator, and then I'll go back and show you how to do it with the calculator. I'm going to do this pretty fast. I've done many videos on this subject, so if this one goes too fast, you can go back and watch one of my earlier videos. This is the function. The first piece is y equals negative x plus 4. Negative 4 is the y-intercept, so that would be like right here. This negative sign is the slope negative 1, so that means down 1, right 1. So that would look like this. And I could go in the other direction like this. Now I'm not going to draw the whole function. I'm only going to draw the part where the x values are less than or equal to negative 3. Now, let's see, which one of these dots is at negative 3? Okay, this is the dot at negative 3. So that's going to be a closed circle because of the or equal. And it says less than or equal, so I want the x values that are to the left. So I'm going to draw the portion of the function that goes to the left. So that's the top piece. Make sure you erase any extra dots if you use this method. All right, now I'm going to graph the bottom piece, y equals 3x plus 2. So that plus 2 is my y-intercept, and that 3 is my slope, so up 3, right 1. So that's going to look like this. Going to the left, I'd be going down 3, left 1. Okay, now using the domain restriction, which one of these dots has an x value of negative 3? So look, here's negative 3. I look down, and here it is. Okay, this needs to be an open circle because it's not or equal to. Now we want greater than, so we want the part of the graph that goes to the right. So that's why I'm going to graph this side of the line, because it's going to the right. All right, and we'll just erase any extra guide points. All right, I didn't think that would work, but I thought I'd give it a try. And that's it. That's how this graph would work. The domain, it goes left forever and right forever. So that's negative infinity to positive infinity. The range, bottom to top. The lowest value is right up to negative 7. So I'm going to have negative 7. And it goes up forever. So that's going to be infinity. Now be careful, this negative 7 is an open circle. So I will show that negative 7 is not included by making this a round parenthesis instead of a square bracket. So that's how you would graph this without using a calculator. Now I'm going to go back and show you how to do it with a calculator real quick. All right, if I was going to do this with a calculator, so first this side, all right, y equals negative x minus 4. So I go to my TI-30XS multiview. I hit the table button, and I need negative x minus 4. So negative x minus 4. Okay, where do I start? At the domain restriction number, so negative 3. All right, just hit enter 4 times. So this is going to be the end point of this piece, negative 3, negative 1. Okay, and this will be a closed circle. So negative 3, negative 1, this will be the end point. Now I want x values that are less than or equal to negative 3. So looking at my calculator, less than would be numbers like negative 4. Okay, negative 4 comma 0. So that's right here. Whoops, that's 0 comma 0. Yeah, so negative 4 comma 0 is like here. And if I could keep going, negative 5 comma 1, negative 6 comma 2. All right, and at that point you see the pattern that it's going up 1 over 1, so you can just finish the pattern to the end of the screen. So there's that piece. All right, now I'm going to do the second piece, again using my calculator. Y equals 3x plus 2. So table function 3x plus 2. All right, again, we need to start at the domain restriction number because this will give us the end point of this piece. So I'm going to start at negative 3 again. 1, 2, 3, 4. So negative 3 comma negative 7 will be my end point. So negative 3 comma negative 7, open circle. All right, I want greater than, so I'm going to pick x values that are below negative 3, like negative 2, negative 1. These are greater than. So negative 2 comma negative 4, for example, would be right there. And negative 1 comma negative 1 would be right here. And so you see the pattern is that it's going up 3 over 1 to the right. So once you see the pattern, you can just continue it. So you know that it's going to be like this. All right, now that's the exact same graph that we got doing it the other way. So you can do it whichever way you want. Now moving on to number 6. Now, it wouldn't make sense to try to use a calculator for this because like y equals 5, that's a horizontal line at 5. Okay, but we want only the part where the x values are less than negative 4. So negative 4. Here's negative 4. All right, negative 4 is not included. We want less than negative 4. Leave it as an open circle, but less than means to the left on this line. So that's the top piece. The second piece. Okay, if we have y equals 2, that would be a horizontal line at 2. Okay. Now, this means between. So between negative 4 and 1. So here's negative 4 and here's 1. And these are the points between negative 4 and 1. the negative 4 side should be a closed circle because it says or equal to negative 4. All right, so that's the middle piece. And then the third piece, y equals negative 3. Well, y equals negative 3 is a horizontal line at negative 3. We want the part that is greater than or equal to 1. Okay, here's 1, and we'll go ahead and make it a closed circle because of the or equal to. Greater than would be to the right. Okay, so this is what this function would look like. Now, the domain and range. This graph goes to the left forever, and it goes to the right forever, and there are no x values that are not included. So negative infinity to positive infinity. The range. We cannot do interval notation like we normally do. This graph only has 3 y values. So we're just going to list them. This entire green portion of the graph all has a y value of negative 3. The blue part, all of these y values are the same. They're all a y value of 2. And this entire red part has a y value of 5. Okay? Because of all the gaps where there are no y values in between these pieces, we cannot just say negative 3 to 5 using interval notation. All right, I'm going to stop this video here. Okay, in the next video, we are going to take these piecewise, we're going to start with the graphs and write piecewise functions that go with them.